Welcome to our section on functions and relations. What's going on? Look here, here's a couple vocabulary terms. The domain is going to be all of the input values, while the range is going to be all of the output values. So it'll be the domain and the range. So let's say, for instance, the definition of a function is every input has exactly one output. So if we look here at this relation of numbers here, you have the inputs here on the left side, and you have the outputs on the right side. And let's look at these inputs. 4 goes with 5. And we can write that as an ordered pair, 4, 5. 8 also goes with 5. And there's the ordered pair, 8, 5. 9 will go with 10. And -5 goes with 7. So if we look here, does every input have exactly one output to make this a function? If we look at the 4 has exactly one output. The 8 has exactly one output. The 9 has exactly one output. And so does the 5. So therefore, this relation of numbers is going to be a function. And if we look here, we can use what's called a vertical line test. You can see I have a red vertical line here along the left side. And I've plotted those 4 points from the previous page. I've plotted those 4 points. And we're going to look at the this vertical line. As it passes through, does it ever touch 2 of these points at the same time? It touches one there, and it touches another one, and another one. So it does not touch 2 of those points at the same time. So the vertical line test will allow us to visually see that that is a function. Those 4 points will be a function. Let's look at this one. The definition of a function is that every input has exactly one output. And if we look at -5, has one output of 10. +10 has one output of 10. 8 has an output of 8. But this is the reason why it's not a function, is because 4 has an output of 5, and 4 has an output of 7. And that's the reason why it's not a function, is because this input of 4 has more than one output of 7. Let's look at this graphically and take our vertical line test here, drag it through, it touches 1 point, and right there it touches 2 points. At that point, we know that it is not a function because it is touching 2 points. So the vertical line test proves that that's not a function. Decide whether this relation is a function, and if it is, give the domain and the range. So I want you to take a moment here to look and see if this is a function. Think about it. Definition of a function is every input has exactly one output. So think about this for 1 second and see if you believe it has, or believe it is a function. You should be looking at these inputs. -2 has one output. -1 has one output. 4 has one output. And 8 has exactly one output. So therefore, this is a function. And the domain That was the very first definitions that we took. The domain is all of the input values. So the domain is going to be -2. Let me put a line down through here. The domain is -2, -1, 4, and 8. While the range is going to be 5, -6, 3, and 2. So this is a function. Let's look at the next example. I want you to take a few moments here to decide whether this relation is a function, and if so, give the domain and the range. So if we're looking at the input, 50 has one output, 72 has one output, -80 has one output, -24 has two outputs. So therefore, this -24 is the reason that this relation is not a function. Since it is not a function, the directions do not ask us to state the domain and range. The vertical line test, like I already said before, it's used to determine whether a relation is a function. And if we look, let's look at the left one, take our vertical line, we're going to drag it through. This function that we're looking at, that v-looking function, it is not touching the vertical line more than 1 point at a time. And so if we slide it over here to the right side now, will it touch this purple function at more than 1 point? And it does at lots of points. Right there is one way to prove that it is not a function. And if we look here, it is not a function here either. So this one is a function. The one on the right is not a function. This one's the same way. If we look here on the right, it's touching at numerous points here, actually at 2 points. It touches right there, and it touches right there. And if we continue, it still touches at 2 points. This is the only place where it touches it exactly once, where it touches the vertical line exactly once. And if we slide it over here on the left side, we can see that the vertical line is touching the graph only at 1 point. No matter where it slides to, it's still only touching at 1 point. And so for this left one will be your function. The right one is not. Let's look here. We have a circle on the left side, so we slide this through, and we notice that it touches at 2 points. It only touches at 1 point right there, and then from there all the way through it's touching at 2 points, and then right about there it's touching at 1 point again. So this one will not be a function because it touches at 2 points. Let's look over here at the right one. Still only touching at 1. Vertical line is still only touching the graph at 1 point. only touching the graph at one point. So it never touches, the vertical line never touches the red graph at more than one point. So it is a function. Function notation. This is going to be a new way in which we write functions for you. It's very similar to what you've been using. The first note I have here is that it is written as the symbol f of x. And you notice I already read through number 2 because it is read f of x. So this symbol up here, when you see it in that symbol, that's f of x. Occasionally we will have g of x. Sometimes you also see h of x. And these are also different function notations that you may use. For our purposes right now, we're only going to use f of x. And the reason why I said that this is it's very similar to what you've been doing, because it allows the symbol f of x to replace y. So if we look here at our examples, what is the only thing different in those two equations there? Is that instead of f of x, we have y, or vice versa. Instead of y, we have f of x. So either way. So whenever you see a function notation written like this, you should think f of x is in place of y. So if we look here, our first example says graph f of x is equal to negative 3x plus 1. And remember, f of x is just like y, and this is in slope-intercept form. And so m is equal to negative 3, b is equal to a positive 1. So let's go ahead and graph this. If b is positive 1, we start by putting our first point at positive 1, and we're going to make our slope a fraction, negative 3 over 1. So that means we go down 3 to the right 1, down 3 to the right 1, and down 3 again to the right 1. Or we could have went up 3 to the left 1, and we have to connect the dots. That was the first part. It said graph f of x is equal to negative 3x plus 1, and use the vertical line test to determine whether it is a function. So we're going to take our red vertical line over here, and we're going to drag it through. It touches the function at one point, still touching at one point. It only touches this function at one point all the way through. So therefore, f of x is equal to negative 3x plus 1. It is a function. It is a function there. When function notation is used, the domain is the x values, which are the inputs, and the range are going to be the y values. So how do we do this? Well, if we're going to use negative 10 for our x value, we're going to write this as f of negative 10 is equal to 3 negative 10 times negative 10 plus 1. And what we've done is we've just substituted negative 10 in for x. So f of negative 10 is equal to 3 times negative 10 is negative 30, plus 1 will give you negative 29. So you can write negative 29. And what about when x is negative 1? You substitute negative 1 in for x. F of negative 1 is equal to negative 3 plus 1, and f of negative 1 is equal to negative 2. So we'll put negative 2 there. Now what about when f of 0 and f of 5? You work those out the same way. F of 0 is equal to negative 3 times 0 plus 1, and f of 0 is equal to, well, we know negative 3 times 0 is 0, and 0 plus 1 is 1. And for the last one, f of 5 is equal to negative 3 times 5 plus 1. F of 5 is equal to negative 15 plus 1, and f of 5 is equal to negative 14. All right, when function notation is used, then the domain is going to be the x values, which are the inputs, and the range will be the y values, which are the outputs. So for instance, if we want x to be negative 10, well then, instead of writing f of x, we're going to write f of negative 10. And we substitute x for, or we substitute negative 10 for x. So this is what we have. F of negative 10 is equal to negative 3 times negative 10 plus 1. And f of negative 10 is equal to 30 plus 1. F of negative 10 is equal to 31. And we fill that in for the y. For the next one here, f of negative 1, now that's going to be negative 1. We substitute negative 1 for x, so negative 3 times negative 1 plus 1. F of negative 1 is equal to 3 plus 1. So therefore, f of negative 1 is equal to 4. And we put 4 in under y. How about when x is 0? F of 0 is equal to negative 3 times 0 plus 1. So f of 0 is equal to, well, negative 3 times 0 is 0. So f of 0 is equal to 1. And for the last one, f of 5 is equal to negative 3 times 5 plus 1. So f of 5 is equal to negative 15 plus 1. F of 5 is equal to negative 14. And we'll put negative 14 in underneath the y. So now we have the numbers on the left are the domain. That would be negative 10, negative 1, 0, and 5. The numbers on the right are going to be the range, which is 31, 4, 1, and 14. And remember, when we're using function notation, the domain is the x values, the range will be the y values. Sometimes you're going to just, given a problem that'll say calculate f of x is equal to negative 2x plus 5 when x is equal to negative 1, 2, and 4. And so that's kind of like what we were just doing. You're just going to have 1, 2, 3 different problems here. So f of negative 1 is equal to, and we substitute negative 1 in for x. There's the first problem. Second problem, we're going to substitute 2 in for x. And for the last part, we substitute the 4 in for x. And you just work these out. So f of negative 1 is equal to 7. F of negative 1 is equal to 7. And the second part here, f of 2 is equal to 1. And then the last part, f of 4 is equal to negative 3. And so your three answers, f of negative 1 is 7, f of 2 is 1, and f of 4 is negative 3. I believe that is all we have today on functions and relations. If you have any questions, let me know.